morning, students. Welcome to the 6th session of probability. In the previous class, we discussed some problems on multiplication theorem of probability and also independent events. In today's class, we will do some more problems on those same topics. So moving on to the next question. So the question is, events A and B are such that P of A equals 1 by 2, P of B equals 7 by 12 and P of not A or not B equals 1 by 4. The question is asking us to state whether A and B are independent or not. Okay, now the solution will start like this. What is given? P of A value is given, P of B value is given. What else is given? P of not A or not B equals 1 by 4. Now we have to see what is, so given P of not A or not B equals 1 by 4, right? So what is P of not A? P of not A is nothing but A dash, right? Or what is the corresponding symbol for or? It is union symbol, right? Not A, or the corresponding symbol for or is union. The corresponding symbol for and is intersection. So or we are going to use union symbol, right? A dash union, not B is nothing but B dash. So what is P of not A or not B? It is nothing but P of A dash union B dash. P of A dash union B dash is nothing but, it is given as 1 by 4. Okay, further, how can I write A dash union B dash as? By De Morgan's law, I can write this as A intersection B whole dash, right? A intersection B whole dash. This is from De Morgan's laws. This is from De Morgan's laws. Okay. Now, how can I write P of A intersection B whole dash? I can write that as 1 minus P of A intersection B. That is equal to 1 by 4, right? How is this? We are getting this from, since P of E dash equals 1 minus P of E, right? P of E dash equals 1 minus P of E. In the place of E dash, here we have A intersection B. So this becomes 1 minus P of A intersection B. Okay. What is P of A intersection B from this? What do we get this as? I can write this as 1 minus 1 by 4. But what is 1 minus 1 by 4? It is nothing but 3 by 4. So using the information P of not A or not B equals 1 by 4, we have found out the value of P of A intersection B to be 3 by 4. Okay, what is the question asking us to do? We have to see whether events A and B are independent or not. So by definition of independent events, what are we to check? P of A intersection B, whether it is equal to P of A into P of B or not, right? So we will consider P of A into P of B. Okay, we are considering P of A into P of B. What is P of A? It is 1 by 2. P of B is 7 by 12, right? So 1 into 7 is 7, 2 into 12 is 24. But what is P of A intersection B? P of A intersection B is 3 by 4. So is 7 by 24 equal to 3 by 4? No. 7 by 24 not equal to 3 by 4. But what is 3 by 4? It is nothing but P of A intersection B. So we can see that P of A into P of B is not equal to P of A intersection B. Hence, what can we conclude? We can conclude that A and B are not independent. So we can conclude that A and B are not independent events. Moving on to the next question. The question is, a die is tossed thrice. Find the probability of getting an odd number at least once. So what is the random experiment in the given question? A die is tossed thrice. So that is the random experiment. Since there are many outcomes in the sample space, we are not going to write the whole sample space for this random experiment, but we shall see how each outcome might be, some outcomes, right? So how will some outcomes be? It will be like this, 1, 1, 1, right? This 1 represents that it is a 1 on the first die. The second one is representing that there is a 1 on the second, and this represents it's a 1 on the third toss, right? And you can even have 1, 1, 2, 1, 2, 3, 1, 2, 6, 1, 6, 1, right? So many outcomes will be there in the sample space, okay? Now, what is the question asking us to do? Find the probability of getting an odd number at least once, right? The question is asking us to find out the probability wherein we get an odd number at least once. So to start this, to solve this question, what I do is we will define an event, okay? I will define event capital A as, okay, getting 3 even numbers, okay. So this is how we start the solution, okay. I have defined an event capital A. What is event capital A? Capital A is nothing but getting 3 even numbers. Now, if this is event capital A, what might be the event A dash? What is the event A dash? It is nothing but the event not A, or the complementary event of event A. So what is event not A? Look at event A. Event A is getting 3 even numbers. So event not A is not getting 3 even numbers, meaning getting 2 even numbers, right? Not getting 3 even numbers might mean getting 2 even numbers, or getting 1 even number, or getting 0 even numbers, or no even numbers, right? So in other words, I can also say complementary event of event A, that is event A dash, I can write it as the event of getting an odd number at least once. I repeat once again. What is event A? Event A is getting 3 even numbers. We have defined event A like that, okay. So when we think about the event not A dash, it is not getting 3 even numbers. Not getting 3 even number means getting less than 3 even numbers, right? Getting 2 even numbers. When I get 2 even numbers, the other number must be odd, right? So that also means getting 1 odd number, or getting 2 odd numbers, or at the most getting 3 odd numbers. So in other words, event A dash is nothing but the event getting an odd number at least once. So what have we done? How have we started the definition? We have defined an event such that the complementary event will be the event required for us to which is asked in the problem. Okay, so what is event A dash? Event A dash is nothing but getting an odd number at least once. Getting an odd number at least once. Now that we have defined event A and we have written event A dash, right? All we have to do is we have to find out probability of event A dash. So our question is asking us to, we need to show that we need to find P of A dash, right? So what is P of A dash? P of A dash in terms of P of A is nothing but, we know that P of A dash equals 1 minus P of A, right? P of A dash is nothing but 1 minus P of A. So we have to find out P of A. Once you find out P of A, you substitute in this formula 1 minus P of A, that will be nothing but P of A dash. Now look at event A. Okay, look at event A. What is event A? Getting 3 even numbers. So how might the outcomes look like? They might look as 2, 2, 2, meaning all 3 numbers are even numbers, or 2, 2, 4, or 2, 4, 6, and so on. Okay. Now we are not going to think of all the 3 trials together. Okay. We are just going to think what is the probability of getting an even number in one particular toss of a die. Okay. Once you find that out, we are going to then use multiplication theorem on probability and find out probability of event A. Okay. Now, what is the probability of getting an even number in one toss of a die? Totally there are 6 outcomes, numbers 1, 2, 3, 4, 5, 6. So that comes in the denominator, 6 comes in the denominator, right? So out of 6 numbers, 1 to 6, how many are even numbers? 3 numbers are even numbers, right? So that I put it in the numerator. So what is the probability of getting an even number in one toss of die? It is 3 by 6. When I simplify this, I can write that as 1 by 2. I repeat once again. Okay, we are thinking of finding out the probability of getting an even number in one single toss of a die. Okay, totally we have 6 possible outcomes. When you toss a die once, we have totally 6 possible outcomes. Which are they? 1, 2, 3, 4, 5, 6. So that I will write it in the denominator. Okay, out of the 6 numbers, how many numbers are even numbers? 3 numbers are even numbers, 2, 4 and 6. So how many number of even numbers? 3. 3 of them are even numbers. So I put that in the numerator. So what is the probability of getting an even number in one toss of die? It will be nothing but 3 by 6. On further simplifying that fraction, we get 1 by 2. So now, what is event A? Event A is getting 3 even numbers. So probability of getting one even number is 1 by 2. Similarly, by multiplication theorem on probability, how can I write getting 3 even numbers? It is nothing but 1 by 2, right, into 1 by 2 into 1 by 2. Okay, so again I repeat, getting probability of getting one even number is 1 by 2, but what is event A? Getting 3 even numbers, meaning I have to use multiplication theorem on probability, right? Getting one even number is 1 by 2. So getting 3 even numbers will be nothing but 1 by 2 into 1 by 2 into 1 by 2. So what do you get? We get 1 minus 1 by 2 into 1 by 2 into 1 by 2 is 1 by 8. 1 minus 1 by 8, we get it as 7 by 8. So So what is 7 by 8? 7 by 8 is nothing but the probability of the event A dash. A dash probability is 7 by 8. What is A dash? Getting an odd number at least once. So that is what the question is asking us to find. So the question has the random experiment is a dice toss thrice. We have to find the probability of getting an odd number at least once. So we have defined an event A, wrote the complementary event of event A, and thereafter we used multiplication theorem on probability to find out the probability of the event getting an odd number at least once. So we got it as 7 by 8. Moving on to the next problem, we have got this problem as 2 marbles are drawn at random with replacement from a box containing 10 black and 8 red marbles. Okay? Find the probability that both marbles are red. Sub-question number 2, first marble is black and second is red. Sub-question 3, one of them is black and other is red. Okay, now look at the random experiment. What is the random experiment in the problem? 2 marbles are drawn at random with replacement. So there is a box containing 10 black and 8 red marbles, right? Totally there are 18 marbles in the box. 10 of them are black marbles and 8 of them are red marbles. So what is the random experiment? 2 marbles are drawn at random with replacement. So how will that experiment look like? 1 marble I draw from this box. Note the color, I have to put it back with replacement. That is the meaning of with replacement. So whatever I take, I replace it back inside the box. Then only after I replace the first marble, I take out the second marble. So that is the random experiment here. What is the question asking us to do? Find the probability that sub-question 1, both marbles are red. Okay, we have to find out the probability that both the marbles drawn from this box containing 18 marbles, out of which 10 are black, 8 are red marbles, are red. So we have to find out that. What we are going to do is, I am going to define 2 events. So we are going to start the solution like this. Okay. So this is solution for sub-question 1. For sub-question 1, I'll define 2 events. Okay, define events. Let event A be. Okay, first marble is red. First marble is red. Event B, second marble is red. So what have I done? I have defined 2 events. Event A is first marble is red. Event B is second marble is red. We have to find out the probability that both marbles are red. So in other words, what should we find? We have to find out the probability of the event A and B. So by data, we need to find P of A intersection B. Okay, but now what is P of A intersection B by multiplication theorem of probability? We know that P of A intersection B is nothing but P of A into P of B bar A. This we know from multiplication theorem of probability. So what is P of A? Probability that first marble is red. What is the probability that first marble is red? How many total number of marbles are there in the box? we have totally 18 marbles. Okay, how many of them are red marbles? 8 of them are red marbles. So what will be the probability of drawing out a red marble from the box? It will be nothing but 8 by 18, right? So P of A is 8 by 18. Okay, again look at P of B bar A. What is the meaning of P of B bar A? Probability of event B given that event A has already occurred. But what is the random experiment? We are drawing 2 marbles with replacement, right? You are taking one marble, noting its color and putting it back. So at every trial, the total number of marbles is not changing. So again, event B is second marble is red. So what is the probability of drawing out a red marble from the same box? It is nothing but again 8 by 18. So I get it as 8 by 18 again. Okay. So I repeat once again, P of A intersection B, we have written it as P of A into P of B. This follows from multiplication theorem of probability. What is P of A? P of A is nothing but probability of event A. What is event A? First marble is red. So what is the probability of picking a red marble out of this box containing 18 marbles, wherein 10 are black, 8 are red? It is nothing but 8 by 18. Okay. Similarly, P of B bar A. What is the meaning of that? Probability of event B given that event A has already occurred. That means that I have to calculate the probability of event B given that event A has already occurred, given that the first marble is already found to be red. But the random experiment is such that you are doing it with replacement. Okay, so basically it does not change anything. The second trial is very much similar to the first trial. So you have 18 marbles total, out of which 10 are black, 8 are red. Hence the probability is again 8 by 18. Okay, simplifying that, what can you write that as? On simplification, okay, this I can simplify it as 2 9s are 18, 2 4s are 8, 2 9s are 18, this is 2 4s are 8, 2 9s are 18, then 4 4s are 16, 9 9s are is 81. So we get it as 16 by 81. So the probability that both the marbles are red is 16 by 81. Further, going forward, look at question number 2. You have first marble is black and the second is red. We are having first marble is black and the second is red. Okay. So this is sub question number 2. It is saying we have to find out the probability where first marble is black and second is red. So how can you define the events? I'll define events like this. Event A, B, first marble is black. Okay, event B, second marble is red. Okay, just like the previous problem, I have defined 2 events here. Event A is first marble is black, event B is second marble is red. Now, what is the question asking us to do? We have to find out the probability that first marble is black and second marble is red. So in other words, we need to find the value of, P of A intersection B. Again we are going to use the multiplication theorem on probability. So what do we know? It is P of A intersection B equals P of A into P of B bar A. But what is P of A? What is event A? First marble is black. Look at the question. How many total number of marbles are there? We have 18 marbles. Out of them, how many are black marbles? We have 10 black marbles. Hence, what is P of A? It will be nothing but 10 by 18. Okay, since 10 of the marbles are black marbles and we have total 18 marbles, we have the probability as 10 by 18. Then look at P of B bar A. What is P of B bar A? Probability of event B such that event A has already occurred. Okay, since again this is an experiment wherein you are replacing the marbles, right? No change. So essentially you are finding out probability of event B. So second marble is red. What is the probability of drawing a red marble from this box? It is nothing but 8 by 18. It is 8 by 18. On simplifying this is 2 5s are, 2 9s are, 2 4s are, 2 9s are. So that is 20 by 81. So what is the probability where first marble is black and second is red? It is 20 by 81. Okay, moving on to the third. Okay, moving on to the third question, sub-question. It is given that one of them is black and other is red. Okay, we have to find out the probability that one of them is black and other is red. This might mean that first is black, second is red, or second is black, first is red. Okay, so both probabilities we have to calculate, and thereafter we have to add both probabilities. Okay, now I will write like this. This is sub-question 3. Probability of one of them is black and other is red equals, I will write this as P of first is black and second is red plus probability of first is red and second is black. So what have we done here? We have taken P of one of them is black and other is red. I have written it as probability of the event. First is black and second is red plus probability of the event plus probability of the event. First is red and second is black. Okay, all we have to do is find out probability of first is black, second is red, and add it with the probability of first is red, second is black. Just like the previous two sub-questions, we are going to find that out. What is the probability that first one is black? Look at the question. Total 18 marbles, out of which 10 black, 8 red. So what is the probability that taking out a black marble out of this box, it is nothing but 10 by 18, right? Into second is red. So what is the probability of picking out a red marble? It is 8 by 18. So what is the probability of first is black and second is red? It is 10 by 18 into 8 by 18 plus probability of first is red. So what is probability of first being red? It is 8 by 18. Second is black. Black is 10 by 18. So I can write this as 8 by 18 into 10 by 18. So this is what we get. Just like the previous two sub questions, this we have done. Then I can write this as, we have 10 by 18 into 8 by 18 plus 8 by 18 into 10 by 18. I can write this as twice into 10 by 18 into 8 by 18. On further simplification, to 5s are, to 9s are, to 4s are, to 9s are, this is nothing but 2 into 20 by 81. 2 into 20 gives us 40 by 81. So what is the probability of one of them being black and other being red? It is nothing but 40 by 81. Moving on to the next problem. This problem states that probability of solving specific problem independently by A and B is 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that there are two sub-questions. Sub-question 1 is asking us to find the probability that problem is solved. Sub-question number 2, exactly one of them solves the problem. Okay, now I'm going to start the solution like this. I'm going to define two events. Okay, we will define two events. Event E, I will define it as A solves the problem. Event E is A solves the problem, and event F, I will define it as B, capital B, solves the problem. Okay, look here, how have we started the solution? I have defined two events. Event E is capital A solves the problem. Event F, I have defined it as capital B solves the problem. But look at the question, probability of solving specific problem independently by A and B, right? So the word independently, what can we conclude? We have defined the events C and F such that E is A solves the problem, F is B solves the problem. So in the problem it is given that it is independent. Both these events are independent events. So events E and F are independent events. By definition of independent events, what can I write? We can write by data P of E intersection F, I can write it as P of E into P of F. Why is this? This is because events E and F are independent events, and by definition of independent events, P of E intersection F, we get it to be P of E into P of F. But what is P of E? P of E is, event E is A solves the problem. Look at the question, problem of solving specific problem independently by A is 1 by 2. Hence, P of E is 1 by 2. Similarly, P of F, event F is B solves the problem. In the question it is given that specific problem independently by capital B is 1 by 3. So, P of F is nothing but 1 by 3. So, 1 by 2 into 1 by 3 gives us 1 by 6. Okay. Now, look at the question. What is the question asking us to do? If both try to solve the problem independently, find the probability that the problem is solved. Sub-question 1 is asking us to find out the probability that the problem is solved. When will the problem be solved? There are two persons here, person A and person B. Either person A needs to solve the problem or person B solves the problem. Even if both solve the problem also, the problem is solved. So the question is exactly asking us to find the probability of P of A union B. So by data we need to find what P of E union F, right? Because we have defined the event E as A solves the problem, event F as B solves the problem. Hence, by data we need to find value of P of E union F. But what is formula for P of E union F? I can write that as P of E plus P of F minus P of E intersection F. So this follows from first PUC probability chapter. This result we have already come across. P of E union F, I can write it as P of E plus P of F minus P of E intersection F. But what is P of E? P of E is nothing but 1 by 2. So this is 1 by 2 plus P of F. P of F is 1 by 3 minus P of E intersection F. Just now we calculated it to be 1 by 6. On simplifying this, the LCM we get it as 6. So what do we get here? 3 plus 2 minus 1. 3 plus 2 is 5. 5 minus 1 is 4. So this is 4 by 6. On further simplifying this fraction, what do we get? We get 2 by 3. So what have we found out? We have found out the probability that the problem is solved. The probability is 2 by 3. Moving on, we have sub-question number 2. Okay, sub-question number 2 is asking us to find out the probability of exactly one of them. Okay, solving the problem. Find the probability that exactly one of them solves the problem. Exactly one of them solves the problem means either A has to solve the problem, B should not be solving the problem, or B solves the problem, A should not be solving the problem. How have we defined the event C and F? E is A solves the problem, F is B solves the problem. So I will write like this. This is sub-question number 2. Probability of exactly one of them solving the problem is equal to, I can write it as P of E dash intersection F plus P of E intersection F dash. So what is event E? Event E, I have taken it as A solves the problem. So E dash means A does not solve the problem. F is B solves the problem. So probability of exactly one of them solving the problem is sum of the probabilities where A does not solve, B solves, and A solves but B does not solve. Okay, we'll find this out. Again, we will use multiplication theorem on probability. Okay, what do we know? The two events are E and F. What is P of E dash? P of E dash is nothing but A does not solve the problem. But what is the probability that A solves the problem? It is 1 by 2. Hence, what is P of E dash? Before that, I can even write P of E dash into P of F. Why? Because these two are independent events. Also here, I can write it as P of E into P of F dash. Okay. How did this step come from? Okay, because E and F are independent events, E dash and F are also independent events. So I can write this as P of E dash into P of F. Here also I can write it as P of E into P of F dash. Now, what is P of E dash? What is P of E? P of E is 1 by 2, hence P of E dash will be 1 minus 1 by 2, right? P of E dash will be 1 minus 1 by 2. Again, P of F, it is already given in the problem to be 1 by 3. Then plus P of E. P of E is A solving the problem, which is nothing but 1 by 2 into P of F dash. P of F is 1 by 3, hence P of F dash will be 1 minus 1 by 3. On further simplifying this, what do we get? 1 minus 1 by 2 is 1 by 2 into 1 by 3 plus 1 by 2 into 1 minus 1 by 3, we get it as 2 by 3. Okay, we'll simplify this. So what do we get? 1 by 2 into 1 by 3 is 1 by 6 plus 1 by 2 into 2 by 3, we get it as 2 by 6. On further simplifying, we get 3 by 6. This again on further simplifying, we get 1 by 2. So what is the probability of exactly one of them solving the problem, either A or B solving the problem, is 1 by 2. Okay, moving on to the next problem. This problem states the probability of obtaining an even prime number on each die when a pair of dice is rolled is. We have been given 4 options. Option A is 0, option B is 1 by 3, option C is 1 by 12, option D is 1 by 36. Okay, the solution will start like this. Again, this problem, as you can see, is based on multiplication theorem on probability. Okay, now we have to think about what is the probability of getting an even prime number when a die is tossed one time. What is the probability of even prime number, getting an even prime number when the die is tossed one time? It is nothing but 1 by 6. Why is it 1 by 6? Because totally we have 6 possible outcomes. Out of those 6 possible outcomes, how many even prime numbers are there? Only 1. That is the number 2. So the probability of obtaining an even prime number when a die is tossed once will be 1 by 6. But what is this question asking us to do? It is asking us to find out the probability of obtaining an even prime number on each die when a pair of dice is rolled. So when 2 dice are rolled, what is the probability of getting even prime number on both the dice? Okay, it is as simple as that. We'll start the solution like this. We will define events capital A getting an even prime number on first toss. Event A is getting an even prime number on first toss. Event B is getting an even prime number on second toss. Event B is getting an even prime number on second toss. So we have defined 2 events. Events A is getting an even prime number on first toss, getting even prime number on second toss. So look at the question. We have to find out the probability of obtaining an even prime number when a pair of dice is rolled. So in essence, what do we need to find? We need to find the probability of the event A intersection B. By multiplication rule of probability, what do we know about P of A intersection B? It is nothing but P of A into P of B bar A. P of A into P of B bar A. But what is P of A? getting an even prime number on first toss. What is the probability? It is nothing but 1 by 6. Again, P of B bar A, probability of event B occurring given event A has already occurred. In essence, this is nothing but probability of event B. What is event B? Getting an even prime number on second toss. That is again equal to 1 by 6. So 1 by 6 into 1 by 6 gives us 1 by 36. So the answer for this problem is option D. So that is about multiplication theorem on probability and independent events. In the next class, we will start with Bayes theorem. Thank you.